Hi everyone! Last week you were doing some practice with balancing equations using different types of models to help you do that. Today I'm going to show you how to do that without a model. You can continue to use the models if you would like to, but you don't have to at this point. But there is a little bit of work that I'm always going to ask you to show me while you balance your equations, and I'll show you how to do that today. So, when we balance an equation, there's two types of work that we can show. Number one, you can show just a list of the atoms, which is what I call an atom inventory. This is something that I would call a must do. You must list the atoms as you try to balance the equation. So one place you can start, some people like to draw a line to separate the reactants and the products. So just draw a vertical line to separate left from right side of the equation. Then what you do is you list the different types of atoms that you have. So on the left side, I have Ba, and I have O, or oxygen. I also list how many of each I have right now to start with. So I have one Ba and I have two O's. On the other side, I also have Ba and I have O, which is important, but I just have one of each. So that's what I call the atom inventory. And then what I like to do, what you want to do next, is to just start to do the work to figure out how can I get these to be equal on each side. So right now, the Ba atoms are equal on both sides. There's one of each on the left and the right, but the oxygens are not. So that means we need to first of all start by trying to balance the oxygen atoms. If we do that, that would mean that we have two of these barium oxide BaO molecules. If I do that, then I have a 2 as a coefficient in front of the BaO. That's the only way for me to get two O's, two oxygen atoms on the right side. If I do that, of course, that means that I'm also taking two of the Ba atoms as well. So now my oxygens are balanced, but my Ba's are not. So that means I need to go back to the left side, and I need to try to balance that by taking two of those Ba's. So I change the coefficient in front of Ba to 2. That gives me two of the Ba atoms. I still have two of the oxygen atoms with my one molecule and the coefficient of 1. So now my equation is balanced. I mentioned earlier there was another thing that you can do if you choose. You can also still show this as a model if you would like to. You do not have to, but some people like to do this just anyway because it helps them visualize it. So what I mean by that is that you could draw some type of colored circle or other shape or something to represent each type of atom. So for example, we could start with a Ba, and then we also have an O2. And so that looks like this to start with. O2. So two of those. Sorry, the shapes are a little uneven. On the right side then I have a BaO, so I have one of each. And then I can show how I would add more to make those. How I would add more to make those balanced. So I still, obviously I don't have the right number of oxygens to start with, so I need more oxygens on the right side. And if I add another oxygen on the right side, I need a full molecule. I need a BaO, so then I need another Ba to make that happen. So now that I have two BaOs, I would need another Ba atom on the left side to make that balance. So then I have another one of those. Okay, so it still works out the same way. I have two Ba atoms. I have one O2 molecule, so one, and then I have two BaO molecules. So same thing. You can write the 1 if you wanted to. You don't have to write the 1. You can also leave it blank. If you leave it blank, then it would look like this, just 2Ba plus O2. We assume it's a 1 if there's no coefficient, we assume the coefficient is 1. So you could also write it like that. That would be totally accurate as well. To solve this type of problem, start the same way. Divide the left and right. Again, list your atom inventory. What do you have on the right side and the left side? I have 3 NAs and I have 1 N to start with over here, and I have 1 NA and then 2 N's to start with on the right. And then choose one to start balancing because both of them right now don't match. You don't have equal numbers of either Na or N. So if I start with the Na, I would need 3 of them on the right side to make that work. So 3 NAs means that would match. I still don't have a match for my N's though, so now I need to have 2 of those on the left side, 2 of the whole molecule Na3N or sodium nitride in order to make this work. So that gives me 2 nitrogens, but it also gives me 2 times 3, right? I multiply those. So 2 times 3 are 6 sodiums. So now I have to go back and I'm going to have to fix what I did on the other side here because I need there to be 6 of those. So instead, I'm going to need 6 instead of just 3. So I have 6 sodiums on each side. I have 2 nitrogens on each side. If I want to, I can add the coefficient in front of the nitrogen, the N2. I don't have to. I could just leave that blank also. That would be fine. One more tip to make things go a little faster is that if you notice that you have numbers that are not going to easily divide into each other, like for example, I had that 3 NAs and I had that 2 N's, one thing that you can think about to make things go faster is to think what would be the lowest common multiple of those two. Lowest common multiple of 3 and 2, of course, is 6. And so that's why I end up with 6 NAs, 6 sodiums at the end. You don't have to do that. You can always just use trial and error. And it might take a while to get to that point anyway where you see those kinds of patterns and you know what to look for. So for today, go to Google Classroom for today's assignment. It's under day 1, the week of May 4th through the 7th. You can either print this out and do it on paper. You can write out the equations in your notebook and just show your work there. Or you can complete the assignment electronically with Notability and turn in that way. Any of those 3 options is totally fine. If you want to include the colored circles or something else like I showed you to represent the atoms, you can. Sometimes people like to do that just because it's easier for them to visualize and they like to have that. You do not have to. You must, however, include the atom inventory list where you list out on the left side and the right side how many of each type of atom you have and show me your work that you did that. And I will always ask you to do that so that I know and I can see and follow what you did. Okay? Have a great day.